listen to this.
Okay.
Okay, so let's try another one. All right, here, this example here. Negative x to the third plus x, or 12x squared minus 17x minus 90. Okay, what's the degree here? What's the highest x?
3.
3. Okay, now remember how many zeros there are is the same number. There's 3 of them. And how many factors? There's 3 of them. Okay, so now I'm going to go into our calculator and type that into y equals.
So we're looking for when y is 0, not when x is 0?
Correct.
Oh. Huh. I can't believe I'm doing this. I'm sleeping in class.
Okay, so I've got it typed in. Okay, I'm going to look at the graph. But again, I might not be able to tell everything from the graph. But look, there's 1. There's 2, but I remember I'm supposed to have 3 of them. Okay, so I can tell that there's 1 at, it looks like -2.
Mm-hmm.
1, 2, 3, 4 at 5. And then it looks, see how there's like the tiny little bit up the top there? Let's
No.
come back down up over here. Okay, so let's go to the table. And let's check at, look at -2, there's a y is 0. So one of my zeros is x equals -2. Another 0 and the y happens when x is 5. So back over here, we're going to say x equals 5. I have a third one. So I'm going to go back down this way. Oh, and there it is. X equals 9.
Yeah.
Okay, so how that changes, that -2 becomes x plus 2. You drop out the equal sign and you put it inside parentheses. The +5 turns into a -5. And then the +9 turns into a -9. Again, drop the equal sign, put it inside parentheses. Okay, and the whole point of doing this is to say, to rewrite this polynomial into this factored form, okay, and they're the exact same thing.
There.
Okay.
But there isn't a 5 in the equation.
There isn't. But that's where I'm not going to teach you guys how to actually do that algebraically. The important part is not to do that, is that you see the connection. Okay, so if you were to type both of those into y equals, actually you would have to put a negative in front in this specific one because of that negative. But if I were to do that, okay, you're going to see, so I'll do that right now. What was it? X plus 2, x minus 5, and x minus 9. Okay, it's just configuring it basically
Oh.
to be the exact same. Look at the table now. So everything is the exact same.
Oh, okay.
Okay, and the benefit, and it's not really a benefit in algebra, but in geometry and in, see how it just went right over that blue line?
Yes.
Is you're going to need this factored form to solve equations later on. So what we're doing in the algebra part of it is just teaching you guys the connection between these two forms. Those are what we call equivalent forms. They look different, but they provide the exact same graph and the exact same table. So it is, in fact, the exact same function.
Okay.
Okay, so that's the whole point of that. And I didn't really get the time to really share that with you guys because we had to talk all about digital learning instead on that Friday before we got closed. But it's a pretty cool connection that I think if you guys do a little bit more practice, you'll be just fine with.
Okay.
Okay.